Hello guys, our project name is IoT Home Automation, presented by Shivam Kumar Tiwari and Nikita Thakur. The content or the topics that we have learned during the internship are programming in C, what is IoT, IoT architecture, what is embedded system, project requirements, all Scilab codes, and lastly conclusive. Now we're moving toward programming in C, that is introduction of C. Here question arises why we need C. Because it reduces the gap between low and high level language and can be used in application level programming. Fewer libraries when compared with other higher level language which build analytical skill because you won't be dependent on programming language entirely for implementing basic function, and moreover you can implement them on your own very fast in terms of execution time. C is used to control microcontroller, which plays key role in embedded system, help in understanding the fundamental of computer theories. Here are some features of C. Procedural languages, fast and efficient, modularity, statically typed, general purpose language, rich set of built-in operator, libraries with rich function, middle-level language, portability and easy to extend. Here are some keywords of C. Keywords of C includes data type, modifiers, qualifiers, loop, jump, decision, storage class, derived, and user-defined others. Data type are char, int, float, double. Modifiers are signed, unsigned, short, long. Qualifiers are constant, volatile. Loops are further divided into for loop, while loop, and do loop. Jump is go to, break, and continue. Decisions are if, else, switch, case, and default. Storage classes are auto, register, static, extern. Derived functions are struct and union. User defined are enormous and type def. Others include void, return, size of. Now data representation, other representation, bits, basic unit of information in computer and digital communication. Bytes are group of 8 bit is called a byte. Group of 4 bit is called as nibble. Word is defined as it is a group of 2 byte or 16 bit is called as word. A double word is 4 byte and a quad word is 8 byte. Now some examples or some data type of C. Signed char, unsigned char, short signed int, short unsigned int, signed int, unsigned int, long signed int, long unsigned int, float, double, and long double. Here the ranges are also included in data type and bytes are also allocated to each and every data type. Moving further, we have conditional construct. Now, conditional statement is divided into two parts, that is if else and switch. If else further divided into if else, if and nested if. Switch does not have any types. Now we have operators. We have total three operators, that is unary operators, binary operators, and ternary operators. Unary operators is plus plus minus minus. Binary operators include or divided into arithmetic operator, relational operator, logical operator, bitwise operator, and assignment operator. Ternary operator does not have any types. Here are some examples of arithmetic operators. We have two values, that is a is equals to 12 and b is equals to 3, and we perform each and every conditions or each and every operators, that is a plus b, a minus b, a into b, and a modulus b. Here we perform arithmetic operation for each and every values given. Now, another examples are logical operators. We have here are examples of arithmetic operation. We have two values, a is equals to 12 and b is equals to 3, and we perform each operation like addition, subtraction, multiplication, division, and modulus. In another examples, we have a logical operator where we have taken a 10, a is equals to 10, b is equals to 4, c is equals to 10, and d is equals to 20, where we perform AND operation, OR operation, and NOT operation. In another slides, we have taken examples of bitwise and relational operators. In same way, we have also performed increment and decrement operator. In next slide, we have examples of ternary operator. In same way, we have assignment operator at last. Now, moving further, we have array. We can use variable like v1, v2, v3 when we need less number of variables, but when we need large number of variables, we use array. Array are sequence of objects which are of same data type. All array consist of contiguous memory location. The lowest address correspond of the first element and the highest address of the last element. Now, declaration and initialization of array. Declaring array. To declare an array in C, a programmer specify the type of element and the number of element required by an array. This is called as single dimensional array. The array size must be integer constant greater than 0, and type can be any valid C data type. For example, to declare a 10 element array called balance of type double, use this statement double balance the square bracket 10. Here, balance is a variable array which is sufficient to hold up to 10 double number. Initializing array. You can initialize an array in C either one by one or using a single statement as follows. The number of values between braces cannot be larger than the number of elements that we declare for the array between square bracket. Now, assessing array element. An element is assessed by indexing the array name. This is done by placing the index of element within square bracket after the name of array. For example, double salary is equals to balance square bracket 9. The above statement will take the 10th element from the array and assign the value of salary variable. Now, pointer. Pointer is store address of variable or a memory. They are declared as follows. Data type are star var underscore name. Example, pointer ptr hold address of integer variable or hold address of memory whose value can be accessed as integer value through ptrn or int star ptr. Feature of pointer used for file handling, used for memory allocation, allocate memory dynamically. Now we have storage. All computers do not store the byte that comprise a multi-byte value in the same order. Consider a 16-bit internet that is made up of 2 bytes. Two ways to store this value. Little Indians In this scheme, low order byte is stored on the starting address and high order byte is stored on next address A plus 1. Big endian is in this scheme, high order byte is stored on a starting address A and low order byte is stored on next address. Moving further, we have OOPS concept, object-oriented programming. Object-oriented programming consists of objects and class. Objects means a real-world entity such as pen, chair, table, computer, watch, etc. Object-oriented programming is a methodology or paradigm to design a program using class and object. Class collection of object is called class. It is a logical entity. A class can also be defined as blueprint from which you can create an individual object. Class doesn't consume any space. We have different types of OOPS concept, that is inheritance, polymorphism, abstraction and encapsulation. In next slide, we have discussed this uh, inheritance. When one object acquired all the properties and behavior of a parent object, it is known as inheritance. Now, moving further, we have pointer. Pointer store address of variable or a memory. They are declared as follow: data type, asterisk, where underscore name or semicolon. Example: pointer ptr hold address of an integer variable or holds address of memory whose value can be accessed as integer value through ptr in or int asterisk ptr. Features of pointer are used for file handling, used for allocate memory dynamically. Now, storage. All computers do not store the bytes that comprise a multi-byte value in the same order. Consider a 16-bit internet that is made up of 2 bytes. Two ways to store this value. Little endian. In this scheme, low order byte is stored on starting address A and high order byte is stored on next address A plus 1. Big endian. In this scheme, high order byte is stored on a starting address A and low order byte is stored on next address A plus 1. Now, OOPS concept, object oriented programming. Object oriented programming consists of keywords such as object and class. First, we define object. Object means a real world entity such as pen, chair, table, computer, watches, etc. Object oriented programming is a methodology or paradigm to design a program using classes and objects. Classes. Collection of object is called class. It is a logical entity. A class can also be defined as a blueprint from which you can create an individual object. Class doesn't consume any space. Now we have inheritance. When one object acquires all the property and behavioral of parent object, it known as inheritance. It provides code reusability. It used to achieve runtime polymorphism. Now polymorphism. If one task is performed in different way, it is known as polymorphism. For example, to convince this customer differently to draw something, for example, shape, triangle, rectangle, etc. In Java, we use method like overloading and method overriding to achieve polymorphism. Abstraction. Hiding internal details and showing functionality is known as abstraction. For example, phone calls, we don't know the internal processing. Encapsulation, binding or wrapping code and data together into a single unit are known as encapsulation. For example, a capsule, it is wrapped with different machine. A Java class is example of encapsulation. The Java bean is a fully encapsulated class because all the data members are private here. Now we have completed the portion of C. Now we move to IoT, that is Internet of Things. Now, what is IoT? The Internet of Things is the network of physical object that contains embedded technology to communicate and sense or interact with their internal states or external environment. The device range from ordinary household object to sophisticated industrial tools with more than 7 billion connected IoT devices today. Experts are expecting this number to grow to 10 billion by 2020 and 2022 by and 2022 billion by 2025. By means of low-cost computing, the cloud, big data, analytics, and mobile technology, physical things can share and collect data with minimum human intervention. In this hyper-connected world, digital system can record, monitor, and adjust each interaction between connected things. The physical world meet the digital world and they cooperate. Architecture of Internet of Things or IoT. We have four levels, that is data gathering, data transmission, process information or smart application. Sensing layer. Sensor actuator devices are present in sensing layer. These sensor and actuator accept data, physical environment parameter, process data and emits data over network. Second layer we have network layer. Internet network gateway. Data acquisition system are present in the layer. DAS perform data aggregation and conversion function, collecting data and aggregating data, then converting analog data of a sensor to digital data, etc. Advanced gateway, which mainly open up connection between sensor, network, and internet, also perform many basic gateway functionality like malware protection and filtering, also sometime decision making based on inputted data and data management service, etc. Data processing layer is third layer. This is a processing unit of IoT ecosystem. Here, data is analyzed and pre-processed before sending it to data center, from where data is assessed by software application, often termed as business application, where data is monitored and managed and further action are also prepared. So here edge IT and edge analytics come into picture. Now the last layer is application layer. This is the last layer or fourth stage of IoT architecture. Data center or cloud is management stage of data, where data is managed and is used by end user application like agriculture, healthcare, aerospace, farming, defense, etc. Now, some characteristics of IoT: massive scale and efficient. IP based addressing will no longer be suited in upcoming future. An abundance of physical objects is present that do not use IP, so IoT is made possible. Device typically consume less power. When not in use, they should be automatically programmed to sleep. A device that is connected to another device right now may not be connected in another instant of time. Intermittent connectivity. IoT devices aren't always connected. In order to save bandwidth and battery consumption, device will be powered off periodically when not in use. Otherwise, connection might turn unreliable and thus prove to be insufficient. Here are some application or uses of IoT: smart grids and energy saving, smart cities, smart homes or smart automation such as smart fridge or smart lighting. We have healthcare, it includes all the wearables or hospital equipment that uses IoT, earthquake detection, radiation detection, smartphone detection, water flow monitoring, or traffic monitoring. Now, here we now after IoT we have embedded system. What is embedded system? Any combination of hardware and software which is intended to do a specific task can be called as an embedded system. It has three parts: software, firmware, and hardware. Unlike computer, embedded system perform few specific limited tasks. Embedded devices have peripherals such as serial communication interface, synchronous serial communication interface, universal serial bus, multimedia card, card compactor, etc. Here are block diagram of embedded system. We have sensor, we have analog to digital conversion, CPU, digital to analog conversion, and actuator. These all are CPU is connected with all this software, memory, and diagnostic port, user interface, FPGA ASIC, and sensor is connected with electromechanical backup and safety, and where the output is given to actuator, and here this actuator input is connected to external environment, and this output is connected to sensor. Now, project requirement: control garden lights on basic of sunlight intensity. Lesser the sunlight, brighter and the garden light. Temperature system control: switch heater and cooler on or off remotely. Switch heater off automatically if temperature indoor exceed to 35 degrees Celsius. Water tank control: switch inlet and outlet valve on or off remotely. Switch inlet valve off automatically if the tank fill up. Switch inlet valve on automatically if volume of tank drops below 200 liter. Requirements: hardware requirements are Arduino Uno, ETH-W5500, PCF 8574, temperature sensor, LCD SD44780, LDR sensor, LED. Software requirements are Arduino IDE to code, PicSimLab for simulation, and null modem emulator to configure port of serial remote tank, Blink IoT app for cloud server. Arduino Uno. What is Arduino Uno? Arduino Uno is based on an Atmega 32/8P microcontroller. It is easy to use compared to other boards such as Arduino Mega board, etc. The board consists of digital and analog input-output pins, sealed, and other circuit. Arduino Uno includes 6 analog pins. Now, component required for project are hardware requirement includes Arduino Uno, ETH-W5500, PCF 8574, temperature sensor, LCD HD 44780, and LDR sensor and LED. Software requirements are Arduino IDE to code, PixSim lab for simulation, null modem emulator to configure port of serial remote tank, Blink IoT app for cloud server. The first requirement of components in this project is Arduino Uno. Arduino Uno is based on an Atmega 32 microcontroller. It is easy to use compared to other boards such as Arduino Mega board, etc. The board consists of digital and analog input-output pins, shield and other circuit. The Arduino Uno includes 6 analog pin input, 14 digital pins, a USB connector, a power jack and ICSP in circuit serial programming header. It is programmed based on IDE, which stands for Integrated Development Environment. It can run on both online and offline platforms. The second component that we required is ETH-W5500. The W5500 chip is a hardwired TCP/IP enabled Ethernet controller that provides easier internet connection to embedded system. W5500 enable user to have the internet connectivity in their application just by using the single chip in which TCP/IP stack 10 by 100 Ethernet MAC and physical embedded. Support power down mode, support wake on LAN over UDP, supports high speed serial peripheral infrastructure. The third component is PCF 8574. The PCF 8574 is a silicon CMOS circuit. It provides general purpose remote input-output expansion for most microcontroller families via the two lines bidirectional buses. The device consists of an 8-bit quasi-bidirectional port and a 12C bus interface. The fourth is LCD HD 44780. LCD HD 44780 is a dot matrix liquid crystal display control and driver LSI display alphanumerically and simple. It is configured to derive a dot matrix liquid crystal display under the control of a 4 or 8-bit microprocessor. Here is the picture of LCD SD44780. Another components we have temperature sensor. A temperature sensor is an electronic device that measures the temperature of its environment and convert the input data into electronic data to record, monitor or signal temperature changes. Now, the another components that we require is LDR sensor. An LDR is a component that has a variable resistance that changes with the light intensity that fall upon it. This allows them to be used in light sensing circuit. The resistance of a photoresistor decreases with increasing incident light intensity. In other words, it exhibits photoconductivity. So this is all about the components that we required for the project. Now we further moving toward the codes that we perform in Scilab. Here are some codes. So this is all about the codes that we required for this project. And now here is step 1. When we load the hex file, so this is the circuit or this is the figure for step 1. Moving toward, here is LDR is high, so LED is on. Here this LED is on. Now cooler is on. Now cooler is off. Heater is on. Heater is off. Inlet valve is on. Inlet valve is off. Outlet valve is on. Outlet valve is off. So this is all the circuit or figure that we have gathered during the process or during the process when we have done that process in our system. We have collected these figure from that only, and so these are the codes that we have run in Pixim Lab for simulation, where we coded whole process of our project. Just a glimpse of all the codes. Now this is a snapshot of Blink IoT app where we perform the whole task when first step 1 when we load the hex file. Second is LDR is high, so the LED is on. This LED is on. LDR is low, so LED is off. Here nothing is blink. Cooler is on. Now cooler is off. Heater is on. Heater is off. Inlet valve is on. Inlet valve is off. Outlet valve is on. And at last outlet valve is off. So now we reach to the end of our project. So we conclude it with our conclusion slide. That is, conclusion of this project is using Blink IoT application and Pixim Lab Simulator simulates home automation where LED, temperature system, cereal tank reassemble, light, heater, cooler and water tank in real time. CLCD act like a dashboard used for displaying the event. Widget from Blink IoT app like button widget are used to control heater, cooler and inlet valve outlet valve. Gauge widgets to display the temperature and volume of water. So thank you. This is all about our project.